All right, folks, this video is about organizing the information you have so that the choosing of the equations doesn't feel so much like guess and check, so that there's a more systematic way of picking the right equation the first time. It's not foolproof. Sometimes it is a little bit of trial and error, but it's going to really reduce the guessing and checking. Okay, and I call it Physics Sudoku. That is not a standard name. Okay, so this is, I guess, why I call it Sudoku, because there's all these boxes. The first column is how you're going to organize your initial conditions, or what is true at t equals 0. So at t equals 0, the object is at a certain location. It is going a certain velocity, include your minus sign if it's going left or down, and the environment is pushing or pulling on it. The second column, you're going to list the output of the functions at a specific time. So the specific time is, this should be lowercase, but the Google Docs needs to correct me. So all of these things are true at this specific time. So it's the location of the object at this time and the velocity of the object at this time. All right, so what I'm going to do is just give you some hints. Again, not 100%, but it'll help a lot. Some hints about what equation you should go to first. So if you know this entire first row, and then clearly you're going to need to know other stuff, but if you know x and x naught, your best bet is probably to start with the position function, because you know the output of this function. So let's start with that function. All right, so I would suggest what you do is, when I do this in class, is draw this empty chart. You don't need to leave this much space, and then just write little notes, like if this row is filled, you use the position function. Okay, so just follow along with, this is what we did so far. We said this row is filled, you're going to use a position function. If the second row is filled, that means you know v naught and v. You know the output of the velocity function. So in your notes, draw a little arrow. So you should have an arrow next to this box. It says, if you know this row, position function. If you know this row, velocity function. Again, those don't always work. This works a little bit better. If you know that, so the red means this is empty. If you don't know the acceleration and you don't care about it. So let's say maybe you went from like 0 to 40 in 13 seconds. Okay, and you want to know how far your car traveled when you went from 0 to 40 in 13 seconds. We don't care what the acceleration is. We could find it. Right, you went from 0 to 40 in 13. You could use the velocity function to find a. But if you truly don't care and this is empty, then if you can put an arrow in your notes next to this box, it's a combination of the fire drill formula, and this is our don't know, don't care about acceleration to find the location. Okay, so if this box is empty, fire drill formula. And then this is the very last equation that we learned. If you truly don't know, don't care about time, then if this box is empty, you might want to use the don't know, don't care about time. Okay, so that's what I call Physics Sudoku. We're not going to do any problems in this PowerPoint, hopefully super short. But what you want in your notes is annotated next to, I guess we started annotated with this row is filled out, that's what you do. This row is filled out, that's what you do. This row is empty, that's what you do. Or sorry, this box is empty, this box is empty, that's what you do. You do not get that little handy kind of hints on the test, but I think you'll do enough problems that you will make it work. Okay, so I'm not doing an example problem because clearly it's about picking lots of different formulas instead of just practicing one single formula. So we're going to continue to use the physics Sudoku as we solve problems in class, but I just wanted you to have some reference of what that means when I say it, and how the empty boxes or the full boxes help you figure out where to start. Thanks for listening.